Hello everyone, today we would like to present our project called Tocfilx. This project is a web calling application that collect movie data from the internet and display it in our web applications. The main objective of this project are the following. First, to extract movie data from IMDb using web crawling technique. Second, to apply regular expressions in Python to filter and process the collect data. Third, to organize the extract data into struct format. Finally, to display the process movie information through our web applications. Hello everyone, today we would like to present our project called Tocfilx. This project is a web calling application that collect movie data from the internet and display it in our web applications. Our website contains a large amount of information, such as movie title, rating, and release year. However, collecting this information manually can be really time-consuming and inefficient, especially when dealing with hundreds of movies. Because of this, an automated method is needed to efficiently collect and manage large amount of movie data. It is where web crawling becomes useful. Web crawling is a technique used to automatically extract information from websites. It allows systems to retrieve large datasets quickly without requiring manual data collections. In our project, we use web crawling to collect movie data from the IMDb top movie page. After collecting the data from the website, the information is usually in unstructured HTML format, which is difficult to use directly. To solve this problem, we use regular expressions, also known as regex, to identify and extract specific pattern from the text. Regular allows us to filter important information such as movie IDs, release year, runtime, and other movie detail. The process data is then organized into a struct format so that it can be used by our applications. The main objective of this project are the following. First, to extract movie data from IMDb using web crawling technique. Second, to apply regular expressions in Python to filter and process the collect data. Third, to organize the extract data into struct format. Finally, to display the process movie information through our web applications. This project uses two main data sources. The first source is the IMDb website. It provides a large collection of movie information such as title, rating, and release year. The second source is the OMDB API. This API provides additional movie information such as poster, runtime.
First is methodology. So we use the React allowing, and we also use the components, and we have used the front end along with the API, and we have used HTML, CSS, JavaScript, React, and GitHub used for the version control and GitHub pages for deployment. We also test that to ensure website loaded movie data correctly and provided responsive and smooth UX across devices. And this is the technology stack over here for backend and front end, and this is the data collections and web crawling. So first we target, second we crawl, third we parse, and fourth we cache. And for REST API designs, it was shown like this. And for the system workflow, end-to-end flow from data to user experience. So firstly, we're going to open the TLC website, then front-end React application is going to load and send requests to the movie API, and then the API is going to return movie data such as title, poster, and description, and then the system processes and display the movie information on interfaces. Then users can browse categories such as for search for movies or select a movie, and when a movie is selected, detailed information is displayed dynamically, and then the system continuously updates the UI based on user interactions. And this is a system architecture overflow for data layer, backend layer, and frontend layer. And this is the user request flow. You can see 1, 2, 3, 4, 5, 6. And this is the frontend page routing. We have 3 pages, which is home page, movie pages, and detail page. And this is the deployment architecture for the GitHub page and render.com.
The front end is built with React 19 and White. Start using Tailwind CSS with client-side routing via React Router DOM 7 and connected to a Python Flask API on the backend. For the component structure, each page is dedicated React component: home page, movies page, detail page, and navbar. React Router DOM 7 handles navigation between pages using browser router and route. Tailwind CSS provides utility first, styling for the dark cinema theme, and White gives us fast hot module replacement during development. On the React side, use stage, manage, filter, and search input, while use effect triggers API calls whenever filter change. The Flask API is called using fetch, with clearly parameters like search, genre, year, min rating, and sort. Responses come back as JSON and are rendered dynamically as movie cards. The UI follows a dark cinema theme. Key design features include a hero banner carousel, a movie card grid, a filter sidebar, a movie detail page, and a fully responsive layout that works across different screen sizes. The homepage has 4 main sections. First, a full with hero banner with the movie backdrop, IMDb rating, generate text, plot preview, and a see more button. It auto-rotates every 5 seconds. Second, a trending section. Third, generate top 10 row for action, drama, crime, and more. And fourth, a new arrival section sorted by release year. Here, on the left sidebar, user can filter by genre, checks boxes, enter release year, select an age certificate, and set minimum IMDb rating. The page header shows how many results are currently displayed. The filter panel supports 5 types of filtering. Genre checkbox for selecting multiple genre at once, release year input, certificate filter, a minimum IMDb rating slider, and a live search bar that filter movie instantly as you type. The movie detail page has 6 sections. A hero banner with a movie backdrop and key info, a full plot summary, a cast display with actor avatars, a movie info panel showing director, genres, and certificate, a technical spec sections with box office revenue and runtime, and an avoid that and rating section showing IMDb score and Oscar data. Here's the detail page.
I would like to explain about how we implement our backend. For our backend, we have the 2 files. The one is IMDb movie crawler and the one is main. We did web scraping, calling the API, and then extract data using the regular expression. We dig in the IMDb movie crawler. For the main, we call the function from the IMDb, and then after that we will get the output. So we use the flag to connect our front end to appear the real data in our website. So for the web scraping, they have the 4 steps. The one is we need to send the HTTP request to get the data and to get the raw data. And then for the 2 is beautiful phrase HTML with beautiful soup, because beautiful soup read the raw data, raw HTML. After the we first look inside the JSON and then fall back to the scanning HTML element if we need it. And then the test step, it extract the movie data. So here we need to use the regular language to extract our movie data. And then the 4th one is we need to save the crawling data into the cache file. But here we just only use for the test, because when testing, if we didn't use we need to crawl again and again. That is why it takes too long. That is why we use the cache. But for the deployment, we didn't use the cache file because the cache file is really big, and then our project, it was scrapping. That is why we put the cache file in our git ignore. And then here we didn't directly web scrap from the IMDb, because IMDb have their AWS bot detection, so they can think about our IP is a bot, so they can block our data. That is why we use the OMDB API, and the OMDB API is a free available big movie database. We can easily get this API key, but there is a free API. That is why they limit the 1,000 requests per day. So our website is 150 movie, so we can only crawl 6 times per day. Here, OMDB API can get the data of year, plot, actor, award, and other data also. So here, regular language, step 3. For regular language, why we need regular language? Because for the backend, when we run it, it just only gives the JSON file, right? So it is really difficult to search and then to extract and then to make to get the real data, to get our target data. That is why we need to use the regular language to search and then to extract what we need. So here, even though we use a lot of regular language in our code, and there is the here I just only talk about the 9 pattern. This 9 pattern is the most important data of our project. So the first one is we extract the movie ID, because IMDb gave the in the URL IMDb gave the movie ID, so we need to extract this movie ID to get the movie data. So here we use the TT because IMDb give the ID start with TT. That is why we need to use TT, and then deploy is mean it can follow the digit between 0 to 9. and then it can be one or more. And therefore, for the pattern 2, we need to extract the release year. For here, we use the D curly bracket 2 because it's me. It definitely follow the 2-digit. And then for the runtime, in our real code, we use the 4 regular language, but here I just only put 1. When we use the 4 regular language is in the JSON or in the text, it can they have a lot of condition, like hour is the long time, or sometimes they can use just only age or something. That is why we need to think about this condition. That is why I write the 4 regular language for this one. And then for the extract many, I also use the 4 regular language because like for to express the many, they can also use the comma, or sometimes they use the 1.3 million or something like that. So we need to consider all of these conditions. That is why I use the 4 regular language there. But here we use the $sign, right? That this means we escape this $sign because $sign in the regular language, $sign have their own meaning. It means the end of the string. So like to be clear, we use the $sign. And then for the count or scaling, we use the /s+ because 1 and then the number, it should be the at least 1 space. That is why we use this /. And then for the detailed language, here we use the /b, right? Because sometimes the text include a lot of the language, but it didn't mean the real language of like instance some sentence is include English, but it didn't mean the movie language is English. That is why to get the real data of the language, we use the /b. And then for the clean movie title, we scrap for the IMDb top 250. They use the title using the ranking, so like ranking 1, ranking 2, something like that. So we need to clean this title. That is why we also use the regular language to clean this one. And then for here, normalization of the rating. And then here like is the round bracket, so it should be exactly in this round bracket. And then here I would like to point out the ignorance. This means even though the input text is small letter, but it can convert to the capital letter to exactly match with the string. And then the final pattern is HTML format. We need to use this, we need to extract this one because IMDb add the random suffix to the CSS. So we need to clear at the start of the beginning. That is why we need to make the HTML format using the regular language. Thank you for your watching.
Okay, this is the website that you can access by this link, right? Okay, maybe this one, it should work. Okay, when we first fetch the website, you're gonna see the homepage of our website like this. It will have a movie here to be recommended right here, new arrival from the newest year, and the top 10 for each genre. Next one is our movie page. This is like the filter page for us. We have total 150 movies, and we can select by the genre. Maybe I want to see the action movie, or I want to see action and animation movie. There's 2. Or maybe I want to see crime with drama. There's like 31 total. Yeah, and you can clear the filter here. Maybe I want to filter by the release year, maybe 1994. There's like 5 movies here. Or you can filter by the certificate like G, PG, or PG-13, or R, NC-17, and NR. And you can this is like top movie in IMDb. The top one is the most rated one, and the last one is the least rated one, but it's still a lot. So if we move it here, move the minimum IMDb rating, it will start to disappear to match this one. Yeah. So now it's 15 in total. You can clear the filter here. And we can search by movie names, genre, and language here. Maybe movie name, I want maybe Lord of the Rings, so it's show like this. Or maybe I want genre like drama. Yeah, it show 113 here. Maybe I want action movie. Yeah, there are 30 results here. Or maybe I want to see a movie with Japanese language. Maybe I search Japan. Yeah, there's 9 in total here. Okay, and moreover, you can combine all the filter together. Like I want drama movie. It's changed from 150 to 113 already, right? And I want it to be come from 1994. There's 5 left. And I want it to only in red R. There's 3 left. And I want it to be more than 9 rating. Yeah, so the result is Shawshank Redemption. And we can click on it so we can see the detail. This is the movie poster, movie name, year of the release, certificate, time running, plot summary, the main casting, then movie information like director, genre, certificate, worldwide box office, runtime, release date, IMDb score, and award like nomination of Oscar and winning total. Yeah, actually we can click on every page of that have movie picture like this, and it will show you exactly the detail of the movie. And this page also work like that too. This one is also the filter for like top 10 of that their own genre like this, and you can clear like that. Okay, and if we finish from the filter, you can go and see our GitHub repository here. This is where the most of the front end work, and the back end, the code is here, but it actually run in Cloud Run, so actual code is here. You can read to it. Yeah, that's it. Thank you so much.